And now we're going to jump back here. You can see that we have some predefined variables for us, max WH. So we'll talk about what this means when we actually use this variable. And specifically for the detection, I don't think this explanation provides enough context. So we'll talk more about that later. But let me run that. And here, non-max suppression. Later, we're going to use this function. I do like this explanation. Basically, this is going to be the maximum number of boxes that we later feed into this non-max suppression function within torch vision. So we can define those variables. Here, we're going to calculate time limit variable that is dependent on the number of images. Save that variable, redundant, multi-label, well, that one is false, and then merge is false. Now we'll calculate T, and then in C, well, we already know we have 80 classes. So MI, mask start index. In our case, we're not going to use the mask because that is used for segmentation and not detection, but we'll create a variable anyways. And we can do this here as well. You can see max WH and no max suppression. Well, we know MI is 85, and then output, as you can see, is an empty tensor of 0 by 6, given that this is 0 and this is 1. So we'll use this variable later. And we can do the same here. Now here in prediction, what we're going to do is we're going to iterate over all the predictions that we have. In our case, we only have one image. So what this is going to do right here, given that our prediction shape is this one, 1 by 25,200 by 85, we're going to iterate over each image. Well, in our case, we only have one. So what this is going to give us, this enumerate for loop, is xi will be 0, and then x will be basically for every index, which in our case is 0 only, and then this will be the output of x. So let me run this. And then we have xi, 0, and then x, which is basically prediction index 0 or index xi, and this is the size for x right now. And then the next thing that we're going to do here is we're going to unpack what this is actually doing. So let me show you. So here we have xc, which as we defined here at the top, let me close this, xc has a shape of 1 by 25,200 of all Boolean data, true and false. So that's the shape of xc. And then if you see, we have xc and then the index xi. Well, we just calculated xi, which is 0. So this part will become this. And given that we're calling index 0, the output of xc will be 25,200, as you can see here. So this one will be a shape of 25,200, and then x, which we now know is this new value, this 25,200 by 85. What we're doing here is out of these values, return the ones that are true. So this one will be either true or false, and we want to return all the predictions that are true. And you could also see this way, return all the predictions that are true or have a confidence threshold above 0.5, and give me also the associated 85 values. So let me run this, and this will make more sense. So the output of x is 9 by 85, meaning that out of all the predictions, out of these 25,200, only 9 were above that confidence threshold. So this might be a little confusing, but that's why I tried to unpack it a little bit here. Now, the term confidence is overloaded, meaning that it can mean different things in the YOLOv5 architecture. And I personally like this explanation from Glenn Jocker, where he explains the differences between these different confidence values. So if I go to this link, we can see that we have primarily 3 confidences. The first one, Objectness confidence, is the score found in the 4th column of the prediction tensor and reflects the model's confidence that a bounding box contains any object, regardless of the class. So the Objectness score is a value between 0 and 1 with the confidence that there is an object. We don't know which one it is yet, but is confident that there is an object there. The class confidences are the scores found in columns 5 and onwards, representing the model's confidence that the detected object belongs to each specific class. So here, these class confidences from index 5 all the way to the end, depending on the number of classes that you have. And this represents the confidence that the object in the bounding box corresponds to that class. And then the last one is the combined confidence, which is the product of the Objectness confidence and the highest class confidence score for a given bounding box, which is used in the final detection output. So with this explanation, let me jump back to our Colab. So our next step is to calculate the combined confidence by multiplying the class confidences with the Objectness confidence. And this is our next step, which, by the way, we can also follow along in our VS Code. Well, here you can see that labels is empty, so we'll step over that. And X, well, we have 9, so we'll step over that. And now we're in this step. Now notice that here we're multiplying the Objectness confidence times the class confidence. I personally like to see it the other way, even though the multiplication is commutative, so in this case, it doesn't really matter, but I'd rather put it in this order: class confidence times the Objectness confidence, because, well, this is the short version, but if we look at the long version, we're actually multiplying the class confidences or scores from index 5 all the way to the end with the Objectness score. So in this case, the order doesn't matter because it's commutative, but if we had a division or subtraction, then it would definitely matter. So when we perform this operation, the class confidences, you can see here, will be overwritten by the values of this operation. And here we're calling it combined confidence to align with Glenn Jocker's description, even though this will be stored inside the class scores variables. So we can run that. And then just to show you this visually, if instead of doing it for those 9 predictions, we select one of them, in this case 4, because I know that one is the maximum. But if we output those values, where you can see that we have the class scores right here. In our case, remember that for the car, this is index 2 for the classes, so 0, 1, 2. So 0.89, the confidence that we have a car in that bounding box. And then this 0.96 is the Objectness confidence that we have an object in that bounding box. So when we perform this operation, multiplying basically the class confidences, each of those multiplied by this Objectness score, we obtain this combined score. And in particular, if we look at the one that we're interested in, this 0.89 multiplied by this 0.96 gives us this 0.86, which in our case is the combined score of our highest prediction. You can see here in candidates, that's what we obtain, 0.86.